Right now you are moving through time, forward, always forward. You don't have a choice. You didn't choose to age from yesterday to today. You didn't choose for this moment to become the next one. It's happening to you continuously, without permission, at exactly 1 second per second. And you've been doing it your whole life without asking the most obvious question. Why? Not why does time exist? That's a different nightmare. This one is stranger. Physics, the most precise description of reality we have ever built, doesn't actually require time to move forward. Not even slightly. The equations work in both directions. Run them forward, they give you tomorrow. Run them backward, they give you yesterday. And mathematically, both answers are equally valid. So the forward direction you experience every moment of your life, the irreversibility, the before and after, the past you remember and the future you can't. That doesn't come from the laws of physics. It comes from somewhere else entirely. By the end of this, you are going to understand something that most people never stop to think about. You are not a person moving through time. You are time moving through a person. Let's start with what time symmetric actually means. And to do that, let's start with something you've watched 1,000 times. A ball rolling across a table. Film it, play it backward. The ball rolls the other way. Nothing looks wrong. Nothing feels wrong. Physics holds. Now film an egg falling off a counter. It hits the floor and shatters. Shell, yolk, white spreading across tile. Play that backward. The yolk and white leap upward. The shell fragments fly together. The egg reassembles itself mid-air and lands perfectly on the counter. That looks insane. But here's what's strange. Every single molecular collision in that backward clip is physically legal. Every one of them obeys Newton's laws exactly. The backward egg is permitted by the mathematics of motion. Nothing in the laws of nature says it can't happen. Try another one. A drop of red ink falls into a glass of water. It blooms outward, tendrils of colour spreading through the clear water until everything is evenly, faintly pink. Play it backward. The pink water draws itself back into a single red drop. The drop leaps upward out of the glass. Still legal, still permitted, still nothing in the fundamental equations that says no. You could do this all day. Heat doesn't spontaneously flow from a cold cup of coffee back into a hot mug. Smoke doesn't pour back down a chimney and pack itself into a log. A burst of perfume doesn't gather itself back into the bottle. In every case, the backward version is physically possible, and in every case, it never happens. So where does the direction come from? That question sat unanswered for most of the 19th century. The one who came closest, the one who cracked it open, was a 33-year-old Austrian named Ludwig Boltzmann. Vienna, 1872. Boltzmann was obsessed with the hidden machinery beneath the surface of things. While most physicists worked with quantities you could see and measure, temperature, pressure, volume, Boltzmann wanted to know what those quantities actually were at the level of atoms. And at the time, atoms were still a theory, a contested, ridiculed theory. What he discovered is one of the most profound things anyone has ever figured out. The direction of time, he found, isn't written into the laws of nature. It's written into statistics. He called the relevant quantity entropy. And here's what entropy actually is. Not disorder in some vague, hand-wavy sense, but something very precise. Imagine a box divided in half by a wall. All the gas molecules in the room are packed tightly on the left side. You remove the wall. What happens? They spread out. Every time, always. Now ask, why? Why don't they occasionally, spontaneously all drift back to the left? Boltzmann's answer was this. Because there is exactly one arrangement where all the molecules are on the left, and there are roughly 10 followed by 23 zeros worth of arrangements where they're spread throughout the whole box. If the molecules are moving randomly, they will almost certainly find themselves in one of those vast spread-out arrangements. Not because a law says spread out, because there are almost infinitely more ways to be spread out than to be packed together. The egg doesn't reassemble because there is one way to be an egg and something like 10 to the power of 23 ways to be shards on a kitchen floor. Entropy is the number of microscopic configurations that look like what you're looking at. High entropy means many configurations, many ways to be that arrangement. Low entropy means few. And the second law of thermodynamics, the only fundamental law in physics that treats past and future differently, says this. Things almost always move from low entropy to high entropy, from fewer possible configurations to more. That's the arrow of time. Not a rule saying, go forward. A statistical near certainty so overwhelming that it might as well be a rule. Boltzmann understood this. He was certain. And it nearly cost him everything. The scientific establishment of the 1890s did not believe in atoms. His entire statistical framework, brilliant, internally consistent, mathematically rigorous, was seen as speculation built on fiction. His colleagues attacked him in print, in lecture halls, at conferences. Ernst Mach, one of the most respected physicists in Europe, was particularly relentless. Boltzmann argued. Boltzmann defended. Boltzmann was brilliant and emotionally fragile in roughly equal measure. What we would now recognize as severe depression followed him for decades. He had periods of manic creative energy and periods of collapse. The attacks on his life's work weren't just professional. They felt personal because for Boltzmann, they were. He had staked everything on atoms being real, on entropy being a statistical truth, not a mystery. In the summer of 1906, on vacation in Duino, Italy, while his wife and daughter were swimming in the Adriatic, Ludwig Boltzmann took his own life. He was 62 years old. Within 2 years, Albert Einstein and Jean Perrin independently confirmed the existence of atoms through their work on Brownian motion. Boltzmann's statistical mechanics became the bedrock of modern thermodynamics. His entropy equation, S equals K log W, is carved on his gravestone in Vienna, a city that didn't believe him while he was alive. He died, his idea survived. But here's where the arrow of time stops being about entropy and starts being about something much bigger. If entropy always increases, if the universe always moves toward more probable arrangements, then right now the universe is higher entropy than it was yesterday. And it was higher entropy yesterday than 1,000 years ago, and higher 1,000 years ago than 1 billion years ago. Which means if you trace entropy backward far enough, you reach a point where it was almost incomprehensibly low. The beginning. The Big Bang. Sean Carroll, physicist at Johns Hopkins University, has spent years working on exactly this problem. His conclusion sounds almost simple. The arrow of time exists because the early universe was in an extraordinarily, almost impossibly low entropy state. Think about what that means. The Big Bang was not an explosion into chaos. It was an explosion into extraordinary order. The universe at its beginning was smooth, uniform, almost perfectly structured, a low entropy configuration that has been unwinding ever since. 13.8 billion years of entropy increasing, stars igniting, burning, exploding, galaxies spreading and colliding, energy dissipating from concentrated forms into diffuse heat, everything slowly but inevitably moving toward more probable arrangements. And your entire existence, every memory you have, every cause and effect you've ever experienced, every before and after in your life, is a ripple on that tide. But here's the question Carroll keeps returning to, and it's the one nobody has answered yet. Why was the early universe so ordered? The second law tells us entropy increases. It doesn't tell us where the low entropy came from in the first place. David Albert, philosopher of physics at Columbia University, calls this the past hypothesis. We have to treat the initial low entropy of the universe as a brute foundational fact, something we assume because the evidence demands it, not because we can derive it from deeper principles. The universe started ordered. We don't know why, we just know it did. And so the arrow of time, the reason you remember Tuesday, the reason causes come before effects, the reason you age and can't unage, traces back to a single unexplained fact about the first moment of everything. At the far end of this story, entropy wins. Physicists call it the heat death of the universe. In the unimaginably distant future, trillions upon trillions of years from now, entropy reaches its maximum. The last stars will have burned out. The last black holes will have evaporated. What remains will be a uniform, featureless, lukewarm nothing. Every arrangement equally probable. No gradients, no complexity, no difference between one region and any other. No more arrows. But right now, you live in the middle of the story, between the Big Bang's improbable order and the heat death's perfect disorder. Right in the narrow window where stars can exist, where water can freeze, where a brain can form a memory. Now let's talk about you specifically. Why do you remember the past but not the future? This sounds like it has an obvious answer. But think carefully. Your brain is a physical system, a collection of atoms following the same laws as everything else. Why should any physical system have records of one direction of time and not the other? Because of entropy. When something happens, it leaves a trace, a record, a lower entropy imprint of a higher entropy event. A photograph is a lower entropy arrangement of silver halide particles or digital pixels that records what light struck it at a particular moment. A footprint is a lower entropy compression in sand that records the weight that pressed it. Your memory of a conversation is a lower entropy configuration of neurons, synaptic weights changed, connections strengthened, that records what you experienced. And here's the key. Those records only form in one direction. A camera records the past because it was physically present when the light arrived. No camera catches future light. No brain wires itself to future states. Records require causal contact, something physically connecting you to the event, and causal contact flows with the arrow of time, which is the arrow of entropy, which runs from the Big Bang. So when you sit with a memory of something that happened when you were 7 years old, you are following an unbroken causal chain that runs from your neurons, back through every moment in your life, back through the evolution of the species that built your brain, back through the formation of the planet that housed it, back through the explosion of the star whose remnants formed it, all the way back to the universe's first moment of improbable order. Your memory of being 7 years old exists because the Big Bang happened. That causality, the rule that causes come before effects, is the same story, just from a different angle. A cause leaves a lower entropy trace in the effect. The bullet hole records the bullet. The scar records the wound. The effect carries information about the cause because the cause had to happen first to produce that specific configuration. Run it backward, and you'd have effects preceding causes, information appearing before events, memory of the future. It never happens not because a law prohibits it, but because the statistics are as overwhelming as any number you've ever imagined. You cannot remember the future. You cannot reverse a cause. Not because some rule says no, because the universe started ordered, and the odds of running backward are effectively zero. That's not a metaphor. That's a chain of physical causation. Now, the reframe. You have probably spent your entire life experiencing time as something that happens to you. A river carrying you forward, a conveyor belt you're standing on, moving whether you want to or not. Time as a medium you exist inside, flowing past you from moment to moment. But there is no river, there is no flow. Physicists have thought carefully about what time flows would actually mean and come up almost empty. 1 second per second is a ratio, not a rate. A river of time would need something outside of time to define its speed. But there is no outside. Time flows is a sentence that feels meaningful and may not say anything at all. What actually changes, the only thing that actually changes, is entropy. And you are an entropy machine. Your heart beating is entropy increasing. Electrical gradients collapse. Muscle fibers contract. Blood moves from order to a slightly less ordered state. Your food digesting is entropy increasing. Complex molecules broken into simpler ones. Energy released as heat. Your neurons firing. Your thoughts forming. Your memories consolidating as you sleep. All of it is the universe moving from a lower entropy arrangement to a higher one at the rate of approximately 1 biological lifetime. Your body is made of atoms forged in the cores of stars that died before the sun existed. A supernova flung them across space. Gravity pulled them into a planet. Chemistry pulled them into a cell. 4 billion years of biological entropy management assembled them into you, a low entropy configuration of staggering complexity. And every day that configuration becomes very slightly less ordered. You age. Your cells make small copying errors. Your tissues accumulate microscopic damage. Not because time is doing something to you, because that's what the statistics of 100 trillion particles almost certainly do. Your sense of now, the vivid, immediate feeling that there is a present moment and that you are in it, may itself be a product of entropy. Anil Seth, neuroscientist at the University of Sussex, has argued that consciousness is a kind of controlled prediction. Your brain is constantly building a model of the world, projecting forward, checking its predictions against incoming sensation, updating when it's wrong. That process fundamentally requires a distinction between past and future, requires a direction. Your experience of time flowing isn't time doing something to your brain. It's your brain, an entropy gradient with a nervous system, doing something to time. The you of 5 years ago was a more ordered configuration of atoms. The you of 5 years from now will be a less ordered one. The direction from the first to the second is not something imposed on you from outside. It is you. You are the arrow of time. You cannot go back, not because the laws of physics prevent it, because the laws of physics are symmetric and indifferent, and the statistics are so overwhelming they might as well be a wall. There are almost no ways to be backward and an incomprehensible number of ways to be forward. Every moment that passes etches itself into the arrangement of everything around it, a lower entropy trace in a world that was slightly more ordered a moment before. You leave marks not because time is soft, but because entropy runs one way, and you are moving along it. The Big Bang handed you this arrow billions of years before you were born. You've been carrying it every second since. You will carry it until your atoms disperse back into the wider entropy of everything. And somewhere ahead, unimaginably far ahead, entropy wins completely. Not just for you, for everything. The last stars will cool. The last structure will dissolve. What remains will be warm, diffuse, featureless. Maximum probability. No more records. No more causes and effects. No more someone to ask why the future is different from the past. But right now, in the narrow, improbable sliver between that beginning and that end, there are stars. There are planets. There are people who remember being 7 years old, who sit somewhere and feel time passing and wonder for just a moment where it goes. You, right now, still moving. What was there before the arrow, before the first moment of low entropy, before the universe could even have a direction, is on the next one.